All right, we'll go ahead and get started. So first of all, thank you for attending. Appreciate you joining this webinar. So what we're going to talk about is the Misconfiguration Manager project that was started by Dwayne Michael, Chris Thompson, and Garrett Foster. It talks about the different attack techniques that you can leverage against Configuration Manager from a offensive perspective, a defensive perspective. It also talks about like detections and some mitigation guidance as well to prevent a lot of these offensive techniques working in your environment. Okay. So when the project started, Dwayne reached out to me and he said, "Hey, do you want to help us work on the detection guidance portion for it?" And I was like, "I'd be more than happy to." Wasn't super familiar with writing detections for Configuration Manager or SCCM specifically. So I took it as an opportunity to do some newer research. And I think I wrote like three or four detections when the project first started. But I had it on my backlist for a long time to write a whole bunch more. So recently, right before the end of the year, I did a bunch of research and added detections 5 through 9 to the Misconfiguration Manager project in GitHub. And so this will essentially be like kind of an update about what those contributions were, the different data models that you can leverage to try to detect these Configuration Manager abuse attack paths in your own environment, and then any kind of operational guidance I can give you about these particular techniques. Okay. All right, so I'll go ahead and start off by introducing myself. So my name is Joshua Prager. I'm a principal consultant on the adversary detection team with SpectreOps. SpectreOps is well known for our offensive research and for our penetration testing and red teaming services, but we also have defensive services as well, a little less well known. We do purple teaming assessments, we do defensive advisory work, we do detection engineering and threat hunting as well. Really just kind of anything that we can do to kind of supplement that offensive service, because what we don't want to do is we don't want to provide our clients a laundry list of findings, a laundry list of attack paths, and say, all right, go figure them out on your own. If we can pair that offensive service with a defensive service to better grow the maturity of that client, we try to do that every time. Okay. So I've been with SpectreOps for 6 years, but I got my start in the U.S. Navy. I joined the U.S. Navy. And I started off as a radio man, on my first ship. Did that for a couple years, went to my second ship, did that for some more years, eventually made it up to information assurance. And then I rotated over to a shore command where I worked with the Navy Red Team, building and managing and supporting their offensive infrastructure. And then I did that for a good while, about 4 years, managing the Navy Red Team's offensive infrastructure. And then eventually I rolled into kind of becoming an operator myself. I did one of those numbers where the active duty personnel leave in a uniform and they come back the next Monday in a suit and tie. So I definitely did that. Came back as a contractor for the U.S. Navy, still working in that Navy Red Team capacity as an operator. Did that for a pretty short while, and then I did a complete shift, and I joined In-Game Systems as a threat hunter. In-Game went through a couple different acquisitions, and I worked with a couple of different those teams over there as a threat hunter. And then eventually ended up at SpectreOps about 6 years ago. And since then, I've been doing threat hunting, detection engineering, compromise assessments, purple team assessments, maturity assessments, and then a couple of penetration tests and red teams here and there as well, just to keep the skills sharp. I do have my master's degree through NYU. I'm part of the NYU Cyber Fellowship program. It was a great opportunity. It was a great program, and I was able to use my military benefits to cover most of the cost for that. So it was an awesome opportunity to join that. And then, like I said, I'm a contributor to the Misconfiguration Manager project. So, I'm not one of the ones that originally started it, but, Dwayne reached out to me and said, like, help us out with the detection guidance, and I was more than happy to do that. It's a really, really great project. Later on, we'll make sure that you get the links to the Misconfiguration Manager project so that you can take a look at it on GitHub, look at that detection guidance, look at that remediation guidance, and as well as the offensive techniques as well. Okay. Okay, so what we're going to talk about is, first I'm going to start off with an introduction to the Misconfiguration Manager project if you haven't heard of it before. I'm going to talk about the impact of some of the configuration manager attack paths that exist. I'm going to do kind of an overview of the updates that I made to the detection section of the project. And then, with that overview, there's going to be like data models that are going to talk about the different event IDs that you can ingest or that you can try to monitor and audit to identify the abuse of these configuration manager attack paths. Okay. All right, so what is the Misconfiguration Manager project? It's a knowledge base of configuration manager abuse, attack paths, prevention controls, and detection guidance. When I first heard about Configuration Manager was years and years and years ago when it was still called SCCM. I think SCCM started back in like 1998. A lot of times we get the question, why is there this like sudden interest in Configuration Manager or SCCM attack paths? And the reason is it's been this thing that we see in all these client environments. And it is oftentimes very much configured with outdated methodology and configured with outdated like configuration guidance. And so because of that, we find that when we're abusing attack paths with Configuration Manager or an SCCM, it's kind of like take one, take it all kind of mentality there. If you can, and we'll talk a little bit about when we get into like site takeover and stuff, but essentially if you can take over in a portion of the Configuration Manager infrastructure, there's not much stopping you from taking over the entire Configuration Manager infrastructure. But like I said, the first time I heard about Configuration Manager was back when it was called SCCM and I was working for the Navy. I remember doing like STIGs and different implementation guidance. And I remember having this thought when I looked at SCCM. I remember noticing that it pretty much does everything as a local admin across all these remote hosts. I remember that the administrative passwords to SCCM were like heavily guarded. And I remember just having this like obvious, light bulb moment where it's like, man, if someone was able to actually get a hold of SCCM in a malicious way, like there's literally nothing stopping them from compromising the entire environment in a really, really difficult to remediate way. And so, fast forward like 15 years, I'm working with Garrett Foster on a red team assessment, and I was in that red team assessment. We had gotten to the point where we had already taken over Configuration Manager. We had already gotten site takeover for Configuration Manager for this very, very large, multiple subdomain, multiple subsidiary company organization. Like we just completely compromised them in this red team assessment. And I was told like, hey, just start making some noise. Do some really obvious poor tradecraft lateral movement techniques just to get the blue team to realize we're in the environment, so they can start, stretching their legs and leveraging some of their detections. So I was doing some like, pretty poor tradecrafty methods of lateral movement, and Garrett looks at me and says, "Oh, are you trying to laterally move over here?" And he just with Configuration Manager, he just passes me a beacon. Like it was nothing. It was trivial to him. He had completely taken over the Configuration Manager site. He had complete administrative control over it, and whenever he wanted to, he could just instantiate a beacon on whatever host was related to that site. And that was like really, really incredible to me. I'm like, wow, like we basically turned this patch management software into our own command and control, right? So around the same time, this Misconfiguration Manager project was coming out, and that kind of aligns with SpectreOps' core pillars. One of those core pillars is transparency. We don't like to be the tip of the spear as far as offensive research and not pair that with some sort of defensive research as well. We're not going to just, we're not one of those we get DA all day type of companies. We want to make sure that if we're using the latest and greatest offensive techniques against you as a client, we want to make sure that there is defensive guidance, remediation guidance that is following that up, so that you can in the future detect these techniques being leveraged and if possible remediate them from being leveraged in the first place. Okay. All right, so just kind of a quick snapshot of what the Configuration Manager project looks like. On that Misconfiguration Manager GitHub, there is this table here. I updated it with the latest techniques on here, but if they've added any more, like in the last week, I might be missing them. But we aligned it with the same kind of taxonomy that MITRE ATT&CK uses, with like initial access, execution, persistence. And then we aligned the offensive techniques underneath that. And then there's another table, and I don't show it in the presentation, but there's another table in the Configuration Manager project where we show kind of like how these offensive techniques will align to one of our remediation guidance or one of our detection guidance as well. Okay. So like I said, yes, we do come out with tip of the spear type of offensive security practices, but we also make sure that our clients are growing in maturity and can remediate and detect the potential abuse of these techniques. Okay, so why did we decide to kind of relate the different offensive techniques to the MITRE attack taxonomy? And it says here like it's because hierarchy takeover via NTLM coercion doesn't really like roll off the tongue, right? We really did our best to try to relate these as possible to like recon, cred, elevate, and takeover. An exec. And I'll talk a little bit about like what each one of these are, what they mean from the perspective of the defensive guidance as well. The defensive guidance will relate to prevent, detect, and canary. Okay. Prevention, it would be like remediation guidance, like how can you configure the environment in a way where these offensive techniques up here won't necessarily work against you. Detection is if someone attempts to utilize these techniques or there is no sort of prevention for them and that technique is executed, can you detect it? Is there some sort of detective control that will generate telemetry and let you know that the attack path is underway, right? And then canary would be like deception technology, right? Can we set something up in a way where it looks like a juicy target? And if you as a red teamer or if you as a malicious actor actually go after this particular object, are you going to generate some sort of event that's going to let us know, hey, someone is falling for our deception technology, and we need to take a closer look at that. All right, so starting off with recon, this is essentially like methods of identifying SCCM infrastructure, okay? There's a bunch of remote ways that you can do this, and we're going to talk a little bit about some of the remote ways that we can do this, as well as how we can detect that as well. But just from a high level, we can use LDAP, we can use SMB, we can use HTTP remote calls to identify that SCCM infrastructure, whether we're querying the domain controller or maybe we're querying a particular distribution point, whatever it is. Additionally, there is kind of like local recon as well. There's a lot of ways that you can identify configuration manager infrastructure locally on a client, a configuration manager client. So like if you as a penetration tester landed on a host, and you go through looking through certain areas, which we'll talk about here in a little bit, you can locally enumerate whether or not it's a configuration manager client, and you can also identify the distribution points, the site servers, and things like that. Okay. Then we have cred. So that's a way we can identify privileged credentials. It leads to like a direct hierarchy takeover or domain compromise. We're going to talk a little bit about how we can detect some of the different attack techniques that leverage or that fall within this like cred category. Some examples would be like extracting credentials or identifying a method that would like lead to lateral movement with those credentials. We also have execution or exec as well. So this would be like various ways that we can deploy an application package, or like I gave you that example of when Garrett Foster just simply passed me a beacon, right? Yeah, I needed to laterally move. I wanted a Cobalt Strike beacon on host B. I was on host A, and he's like, "Oh, I have complete site takeover. So let me just start you a beacon on host B." How that actually happens, how do we actually deploy an application, how do we get it to execute? This would all fall within the exec category. Okay. Some interesting points to focus on for execution is that essentially for a lot of the application deployment parameters that are requested, a UNC path is basically the bar to entry. And if you're familiar with like a UNC path, it can be something that's remotely hosted. It could be something that's locally hosted on the remote destination end. It can also be something that's locally hosted on the attacker controlled side as well. So really bar for entry here is just a UNC path. And then we talk about takeover. So takeover or site takeover are mainly using coercion techniques. But the goal here is to take over a portion of the configuration manager infrastructure that would allow us to take over the entire site. In many cases, because of the way Configuration Manager was stood up years and years and years ago, and no one stopped to change it, because why fix something that it ain't broke, right? If you can take over one portion or one site, you can essentially take over the rest of the site as well. And we'll talk a little bit about that. All right, so what's the impact with Configuration Manager? So in most cases, organizations will use SCCM to manage those critical tier 0 assets, as well as all the rest of their infrastructure, okay? We've seen Configuration Manager deployed to domain controllers. We've seen them deployed to root CAs. We've seen Configuration Manager agents all over the place. It's essentially so they can push applications, scripts, reconfigurations, patches, right? It's a very, very, very commonly used Microsoft tool to manage infrastructure, to manage the actual machines in your network. So it makes sense that everything that's associated to that particular site would be controllable by Configuration Manager. So, 1+1 is 2. It's not super difficult to see why Configuration Manager makes a very, very juicy target from the perspective of offensive attackers. Okay. One of the big impacts with site takeover is that it essentially enables us to take over a full control of the system hierarchy. Okay. And the reason for this in most cases is because the site databases are replicated to all the sites within that hierarchy. We're going to talk a little bit about what that means here in a little bit. But essentially, if I add an administrative user, we'll say that, this is bad user. If I add bad user to the site database on one site that I have access to, that admin in that database is now replicated to the entire hierarchy, and I can essentially control all the sites. So it's a really, really it's a really obvious attack vector when you really start to think of it that way. Like it says there at the bottom, right? If an attacker takes over one primary site, they essentially take over the entire thing. In most cases, there's very rarely where that's not true. All right, there's a whole bunch of different takeover attack paths. Most of them are leveraging coercion. So like takeover 1 is NTLM coercion to the MS-SQL database. Takeover 2 is coercion to remote site databases. Coercion 3 is utilizing coercion and relay to ADCS. It's essentially like the different takeover paths are just really just changing, like what are we coercing and what are we aiming that coercion or I guess what are we aiming that relay at, right? Whether it's like an origin primary site server, SMS provider, or passive site servers or the domain controller, we're essentially just coercing the authentication from the actual site server, and we're passing that site server authentication over to a site database, an ADCS server, whatever our target is, okay? We're mainly leveraging this method of coercion because the primary site server's domain computer account is usually a local admin on the site database server. It's typically a sysadmin in the site database and a local admin on every other system role. So to kind of explain it in another way, why am I coercing and then relaying the primary site server? It's because it's basically like local admin on most stuff that would fall under its purview for that particular site. Okay. And in order for these takeover attacks to work, these 3 bullets essentially have to be true, right? And we've ran into situations before where we've tried to coerce the site server and we've relayed it to another target, and for whatever reason, it was configured in a way where it wasn't able to gain local administrative privilege on that target. But I would say like in 90% of the cases, the primary site server is a local admin on pretty much every other site system within that site. So essentially coerce the primary site server, relay its NTLM authentication over to another target, and you have local admin on the domain controller. You have local admin on the ADCS server, whatever that target is. Okay. Okay, so what are we going to be focusing on? I'm going to be talking about monitoring application deployments, monitoring group membership changes, in particular that SMS admins group, which I'll explain here in a little bit. We're going to be talking about monitoring group membership changes in the RBAC admins table within that site database. Talking about read access to SMS temp and why that can be leveraged as a good method of detecting someone trying to steal Pixie creds. We can talk about monitoring the WinReg name pipe for connections, and then monitoring local SCCM file access for kind of that local enumeration that I talked about at the beginning. Okay. What we're not going to be covering is all the offensive techniques that Misconfiguration Manager contains. There's a lot of them. And Garrett and Dwayne and Chris have quite a few talks they've given and quite a few talks lined up that are going to cover the majority of those offensive techniques. I'm mainly going to be talking about the ones that are applicable to my detections that I wrote. We're going to be talking, or not going to be talking about preventative control walkthroughs. We do have an entire prevent section in the Misconfiguration Manager project. Many of these techniques can be prevented in some way just by configuration changes. Not all the configuration changes that we recommend are something that can be done quickly. And I told you at the beginning, I'll try to give you operational guidance. So like, reconfiguring your environment in a way where NTLM coercion and relay won't work is very, very difficult. We were teaching our IDOT course last year, and one of the students said like, hey, we added in the recommended mitigation steps, and it took us about a year of testing and careful reconfiguration to actually successfully reconfigure our environment in a way where NTLM coercion and relay will not work. And I mean, that's amazing, but it's not something that can just be, there's not some magical switch that you just click and it's like, all right, NTLM coercion doesn't work anymore. It does take some testing, but we do have an entire prevent section in that Misconfiguration Manager project where we talk about the different methods of essentially putting things in place to stop these offensive techniques from happening. And then I'm not going to be talking about comprehensive treatment of like the different topics. We just don't have time. Like I would love to, and I can talk about this all day. And if you ever see me in person, feel free to ask me about any of this, and I will brainstorm like the best of them. But everyone's got work to go back to, and we don't have all day to talk about this. All right, so let's talk about application deployment. How can we monitor application deployment? So typically, when a configuration manager application, I'm going to say application in air quotes, because an application deployment is actually made up of a couple different things. But when it's typically deployed, there are some steps that have to be done. One, there usually has to be a collection of devices, okay? This collection of devices could be one device, right? When Garrett Foster passed me that beacon, his collection of devices was one device. It was host B, and that's where I wanted to go. We also have to create an application and a scope. So when we create the application, we're actually giving it a UNC path that says where that binary exists. Now, that UNC path could be a binary that's hosted remotely, right? Maybe Configuration Manager has access to the share drive, and Configuration Manager has access to PSExec that lives on that share drive, or maybe it has access to sysinternals procdump that lives on the share drive. And you can pass it the UNC path of that binary that exists on the share drive, and then you can pass it the requirements to execute on that remote system. And you're essentially telling it to like, hey, go grab this binary, execute it on the remote system. And then you can, do the same thing again and pull back that data or whatever you want to do with it. And in the case of like where I was on that red team op, we were hosting up a beacon and we gave it the UNC path of that beacon. And we said, hey, go pull that beacon and then go execute it on host B. And that got us a callback, right? And then we have to actually create a deployment. That's where we give it this particular configuration settings of like, how do we want this to be executed? And how do we want it to be executed? And what functionality do we want to pass in there specifically to that remote system when that deployment package is sent? And then we initiate the deployment. So luckily for us, there is this log provider that Configuration Manager provides called the status message queue, okay? And the status message queue is actually kind of made of two different log sources. One of those lives on the primary site server, and it's called smsprov.log, okay? The other one is actually like SQL table information. And so the way it works under the hood is I'm using Sharp SCCM, and I want to deploy PowerShell, a PowerShell encoded command to a remote system. I go through the steps that I showed you over here, right? I create a collection, I create an application, I create a deployment, and then I initiate the deployment, all with Sharp SCCM. What's going to happen is when these different I guess things are instantiated, these different events are instantiated, that's going to be represented in the smsprov.log. But what's going to happen is you see, notice here where it says like description and it says user, and then it has the like aperture SCCM admin in quotes, and then created a collection, and then you have device, and then whatever this device GUID is in quotes. So everywhere there's quotes, smsprov.log is actually going to have an SQL query where it's trying to query the site database server to get back the answer for who the user was that started this and who the device collection was that they're using it against. Okay. So if you were to, stand up your own Elastic security, like maybe you have Ludus Lab and you're using the SCCM Ludus Lab instance, and you're like, I'm going to go ahead and roll in those Elastic security Ansible roles as well. So I have Elastic security, so I can take a look at this from a defensive perspective. If you're to go use Elastic security and just pull the raw smsprov.log, it'll probably parse correctly within Elastic security. However, everywhere that you want to actually see who the user was or what they did it against or what application was actually being passed in this application package, you're going to get an SQL query instead of the actual answer. So it takes a bit of nuance. There is a way, I think, with Splunk and the universal forwarder that you can actually set up configuration manager status message queue logs going straight into Splunk, and it'll contain both the SMS prov log portion as well as the SQL, the MS SQL site database information as well to kind of give you one complete log there. But by default, like if you're just to pull this raw log with Elastic Agent or something like that, you're not gonna be able to really see anything other than a user something, like somebody created a collection called something, and you're not really gonna be able to see what that is. Okay. All right, so there are individual event or I guess they're called message IDs in the status message queue. There are individual message IDs that are related to the collection creation, the application creation, the deployment creation, and then that deployment initiation. So we have 30015, 30152, 30226 showing us that like something went and created the application deployment, and then we have event or message ID 40800 that shows the actual initiation. One thing that I noticed that that like Garrett Foster and Chris Thompson, Sharp SCCM and SCCM Hunter will do, when they go and they create the application deployment, a lot of times it'll finish it off with this like GUID at the end of that. In most typical scenarios, like if you're actually looking at this for like a compromise situation, at least I would hope so. Like you're not going to have this GUID after it. Okay, it's kind of like a signature of the tool itself. It's not really a good detection mechanism. So please don't write a detection that says, give me any sort of message ID 40800 where there's a GUID or like a randomly generated ID at the end of it, because that's not realistic. Most often, if you were to go and change Sharp SCCM or SCCM Hunter to make it more like tradecraft mature, you would just kick off that piece of that GUID in there, and then you would name your application deployment something that matches what actually exists in the environment. Okay. What would indicate something is a little bit suspicious though in this case is the actual user that's deploying it. So in most client environments that I've spoken to, it's usually like the same folks who have the same rights to deploy applications in an environment. If I was a user and Josh all of a sudden started making, configuration manager application deployments, that would be super suspicious if I wasn't part of, but like I wasn't known to be part of the groups that are allowed to do this. And we're going to talk about what those groups are here in just a second, okay? All right, so talking about group membership changes. So I'm going to talk about two different groups. And notice I have here, it's like Misconfiguration Manager, detect 5 and 6. So 5 is talking about SMS admins. 6 is talking about RBAC admins. These groups are not the same, but synonymous, sort of. So SMS admins represents the actual security group that is associated to the site server itself. The users that are members of the SMS admins group essentially have access to this WMI provider called SMS provider, which gives direct write access to configuration manager. So as you can imagine, being part of the SMS admins group is essentially a way to elevate yourself to having administrative control over configuration manager. Okay. Now, when a user is added to the RBAC admins table in the SQL database server, the SQL database server backs the primary site server. Okay. So when you add a user to the RBAC admins table in the SQL database server, that will essentially add that member to the SMS admin security group. Okay. And when that happens, you're essentially giving someone RBAC extended permissions to that SMS provider, which allows them to have that direct write control over that SMS provider. And remember, like we talked about 5 or 6 slides ago, if you are an admin in one site server and you've been able as a pen tester to add yourself to that RBAC admins table on one site server, that replicates across the hierarchy. So now you're in the RBAC admins table for every MS SQL server that backs a site server across the entire hierarchy. Okay. So what we can do is we can leverage event ID 4732. A new member was added to detect any sort of changes. Most often, I mean, I've tested this in one client environment. I haven't tested it in more than one. But for that particular client, yeah, it was like well known who those members of the SMS admin security group were. So if all of a sudden a user is adding themselves to SMS admins, this event ID 4732 with a new member added would stand out as very, very malicious. It would be a very high fidelity detection. Okay. But how do we do this to monitor the RBAC admins table, right? We don't have some like default Windows security event ID to tell us when someone is modifying a MS SQL database, right? So MS SQL database has the ability to do what's called custom SQL audits. And inside of custom SQL audits, you can point where you want your particular event ID to be generated. I think the test that I did inside of the Misconfiguration Manager project, I decided to shoot it over to the application log, but I don't think there's anything stopping you from specifying security log or system log. But essentially what's going to happen is you're going to make your own event ID, and you're going to say, monitor changes to the RBAC admin table, and let me know when there's an insert into the RBAC admin table or the RBAC extended permission tables. If there's an insert into either one of those tables and you've turned on this custom SQL audit, you're going to get an event ID 33025, which is actually like a really, really verbose log. It was kind of nice. I had to actually like snip it a couple parts because it was just so long. But you can kind of see an example here of an insert of a user into the RBAC admins table. The object name is RBAC admins, and it was an insert in there. And we see test subject 1 was the user that was inserted into that RBAC admins table. Okay. And then here's just kind of like a data model showing the same thing here that we already talked about. Additionally, there is one more event ID that we can use, and that's if a user is removed from that security group, that SMS admins group. I'm not quite sure why that would be as useful as seeing if someone added a new user to the SMS admins group. You definitely want to make sure that you're monitoring that event ID 4732, where you're focused specifically on the SMS admins as that security group, because ideally, security engineering and support should never be just like randomly adding new users to the SMS admins group. It should be like 5 folks who do this, every patch Thursday, and that should be it. Okay, shifting gears completely, kind of like moving away from talking about the site database itself, and let's talk a little bit about some methods of gaining credentials. Okay. So detection 7 shifts gears completely, and we talk about PXE boot or pre-execution environment, right? So what we can do as adversaries or as red teamers, right? We can recover domain credentials through PXE media, especially if weak passwords are used. There's a lot of tools out there that'll do it. I think the one that I did the test with was like PXE Thiefy. There's a couple of different tools out there that can do this, and they're very efficient at doing it. But I've noticed that a couple different tools will kind of operationally work in the same way from a high level. So most of them are going to seek out or try to connect to a distribution point over SMB. Then they're going to connect to this remote install or REM-inst share, which is where the Windows deployment services are being hosted. And they typically contain PXE boot files. These are like .var extensions and things like that. Inside this REM-inst share that's being hosted for Windows deployment services, there's this directory called SMS temp. And SMS temp is what holds all these .var extensions. And so what we can do is we can set SACLs on this particular directory itself. If you're not familiar with what a SACL is, when I was a blue teamer, growing up in blue team space, I kept hearing everyone talk about SACLs, but I didn't really know what it is. And that was a bit frustrating for me. And then when I Googled it, it's like system access control list, which isn't like inherently obvious what it is. So I'll give like the too long didn't read on SACLs for anyone who's not familiar with it. Um, so you have ACLs on everything in Windows because everything in Windows is an object. Okay, so start with that mentality. Everything in Windows is an object. Every object has a ACL, and then these ACLs are split up between a DACL, which is a discretionary access control list, and a SACL, which is a system access control list. So every object in Windows can say who is allowed to access something or who is not allowed to access something. That is the DACL, the discretionary access control list. The SACL says, what do I want to audit on this object? What do I want to see? Do I want to see someone touching the object? Do I want to see someone modifying the object? Do I want to see someone enumerating the object, deleting the object, copying the object? That's the SACL, okay? It enables you to have advanced auditing capabilities on an object in Windows. And remember, everything in Windows is an object. So there's really not stopping you from putting as many SACLs out there as you want, as much as your ingestion rates can afford, okay? And of the defenders that I talk to who know what SACLs are, the next thing I usually get back is, I can't turn on SACLs. They're too verbose. I don't have the ingestion rates that can handle that. We can exclude particular events at the data shipper level. We don't have to ingest all 4662 or 4663 SACL events. We can just look for the particular ones that contain the objects that we are really, really concerned about. In this case, it would be the SMS temp directory, okay? So of all those different recon commands that I showed you, whether we're connecting to the distribution point via SMB, over HTTP, if we're using, whatever method we're using for reconnaissance, we can set a particular SACL on that remote install or SMS temp directory. And as soon as, a user is accessing it, it'll grab the user that accessed it, what host they accessed it from, and I think what process they used to access it. I could be wrong on that one. I don't remember. Additionally, you can also turn on the detailed file share log as well. So if detailed file share is turned on for the distribution point, and this is important to remember, you can't just turn on detailed file share like on one part of the network and be like, all right, I see all detailed file share events. You have to turn it on the individual host that is hosting the file share, okay? So if you turn on the detailed file share eventing or auditing on the distribution point, you're also going to get a generated event ID 5145. That's the detailed file share. And that log is really, really helpful because it not only tells you that someone accessed SMS temp or remote install share path, it'll actually tell you which particular var file that they accessed as well. And if you're using a tool like Sharp SCCM, which kind of just enumerates through all the different var files and tries to find some sort of pixie creds, or actually, no, not Sharp SCCM, SCCM Hunter or Pixie Thief or Pixie Thiefy. It'll just kind of go through all those different variable files to find the pixie creds. You'll get individual 5145s for each one of those files that are in there. So it's a pretty powerful detection method as well. All right, and so coming up to detection 8 and 9. So again, this is kind of shifting gears, but still kind of staying in the same idea of being able to set SACLs. So if you remember me telling you at the beginning that we not only have a way of enumerating SCCM infrastructure remotely, and I said like there's LDAP, there's SMB, there's HTTP, we can use SMB name pipes, you name it. We can identify these SCCM infrastructure pieces remotely. We can also do it locally, okay? So if a machine is part of an SCCM site, right? It's considered a configuration manager client. It's going to have this area in the Windows directory called cwindows CCM cache, CCM setup, and CCM logs /smsts.log. And inside of CCM/logs, there's actually quite a few different log files that you can use. I just kind of like gave an example of these. I think there's like 6 or 7 altogether. It'll tell you exactly, what the distribution point is, what the most its particular site server, like you name it, all the infrastructure that's needed to target SCCM, you can just find it locally on that. Okay. All right, so looking at the remote enumeration capability, right? So this is like I'm using SMB or HTTP to identify whether or not SCCM infrastructure exists out there. You can also use name pipe enumeration. One of the newer techniques that Dwayne, Chris, and Garrett added to the Misconfiguration Manager project was using the WinReg name pipe to make a connection out there and to enumerate configuration manager infrastructure. I tested looking for the WinReg name pipe in a client environment, and it was a pretty beefy client environment. And I saw like zero WinReg name pipe events out there. I need to test it in a second client environment to definitively say like, yeah, this is like almost not used ever. But I don't want to promise you something and then you go test it and it's like, oh yeah, WinReg is used 10,000 times a day. But in the one environment that I tested it in, it was like never used. So it stuck out like a sore thumb. But you can use sysmon event ID 18 to see connections to that WinReg name pipe. Additionally, if you set detailed file share auditing on the distribution points or on any of the SCCM infrastructure, and that WinReg name pipe is being connected or is connecting to any of that SCCM infrastructure, it will generate an event ID 5145 telling you what exactly within that WinReg name pipe directory or UNC path was being accessed. We can also set a SACL on the SMS distribution point when we're talking about like local enumeration. So we can take a look at like there's particular registry keys on the system itself that'll let you know what the nearest distribution point is. We can set a SACL on that, and it'll essentially tell us like the user that accessed it, the process that was accessing it, and like the different event details related to accessing that particular registry key path. It is an HKLM though, so the adversary would have to have had some sort of elevated access to that registry path location. And then there is LDAP diagnostic logging. Now, LDAP diagnostic logging is a whole talk for another time. I teach a lot about it in our IDOT course. I teach a lot about all of this in our IDOT course. But LDAP query logs are like it's a whole thing all on its own. But you can use diagnostic logging event ID 1644 to detect anywhere a query contains the string SCCM or MSSMS. That'll match most of the known tooling out there. This is a very precise detection and can be very easily evaded. And I've never seen a client actually turn on LDAP diagnostic logs. So just keep that in mind as well. And then we'll come up here to our last detection where we're just talking about local enumeration of files. So you can set a SACL just on the C Windows CCM directory, and then choose to ingest only where there's some sort of like anomalous access to it. Or you can say like anytime that they're going after a particular log file, such as logs smsts.log, where it contains that SCCM infrastructure in there. But like I said, everything in Windows is an object. You can set a SACL on those objects. You can also do a preventative control and reconfigure the DACL so that only certain things or certain privileged accounts or privileged processes can access these log servers, essentially blocking an adversary from being able to access it. And that takes us right at 45 minutes. Here's all the different references that I used in here. Nico and I have given quite a few talks on similar configuration manager abuse attacks. So definitely take a look at that as well. And that's it. So we got any questions? I'd be happy to answer them. And actually, I don't know if I have to do anything to turn on the question capability.
Nope, the Q&A is open, so if anyone has any questions,
Okay.
they can go ahead and type in and submit.
Good deal. Thank you all so much for joining. I really appreciate it. I'll stick around for like a little bit of time, and then feel free to ask any questions that you have. Yes. Ed, you had a question? Oh, sorry, I gotta allow you to talk. There you go. Go ahead, Ed. From my end, Ed, it looks like you're muted. I don't know if it'd be easier just to maybe write the question in the chat.
It looks like there are a couple questions that came in through the Q&A. So we have one that asks, what are the SpectraOps classes that leverage this info?
Oh, that's a really good question. So our like newest course that we have that we've created is our identity-driven offensive tradecraft class. It's really focused on identifying attack paths in the environment. And so that particular class will talk about the Misconfiguration Manager project as well as Configuration Manager just leveraged as an attack path itself. It's a really great class. It's supposed to be kind of like a addition to our Red Team Operation course, kind of like our Red Team Operations 2. But I've actually been suggesting it to a lot of our defensive focused clients as well, because a lot of them want to know the same information. They also want to be able to identify if Misconfiguration Manager is poorly configured in their environment. And they also want to know like detection guidance and remediation guidance. So I've been suggesting it to a lot of like defensive focused folks as well. Because it's really powerful information, and we cover a bunch of different technologies that leverage attack paths, not just Configuration Manager. And then I reading the question here. It sounds like NTLM coercion is one of the key takeover tactics. If NTLM coercion techniques are blocked, does it interrupt most SCCM related takeover attacks? Most of the SCCM takeover attacks, if not all of them, are focused on relaying that site server's authentication to a different target. So yes, if if you've configured your environment in a way to block NTLM coercion and NTLM relay, then yeah, essentially like they would not be able to take those creds and they would not be able to take the creds of the site server, which typically has full administrative rights to any client in its site, and relay those to any of those clients. There are some other offensive methods that might still like be really damaging or concerning, especially a lot of the cred techniques in the Misconfiguration Manager project. Like the one where we talked about Pixie boot. Like maybe they can't relay the site server, but I still don't want someone in my environment able to take the domain credentials in my Pixie configuration settings and try to like do something with those. So definitely a good question though. Anybody else? Anybody else got any other questions or want me to cover anything a little bit more in depth? All right, folks. Yeah, absolutely. If y'all have any other questions, feel free to reach out to me. I'm on LinkedIn, and also on Twitter and Blue Sky, I think is what we're using now. I'm around. You just type in Josh Prager and SpectraOps and I show up like 15 times in Google. Just feel free to reach out to me. I typically will try to get back to everyone who asks me any questions, because I really enjoy talking about this stuff. And it doesn't even have to be focused on Configuration Manager. I'm happy to talk about anything defensive or offensive. And if you have an opportunity to get to our SoCon, our SpectraOps conference in DC, highly recommend it. Take a look at our events page to see like, the next upcoming public trainings if you're not able to make it to that one. And if you see me in person, feel free to tell me like, hey, I saw your webinar, it was great, and it'll be good to meet you in person. Okay. I'll go ahead and close the room. Is that okay, Ashley?
Yep, we're all good to end.
Okay, sounds good. Thanks y'all. Take it easy.